Here in our lab at NASA Langley, we use a technique called active remote sensing. Now that means that we carry our own light source. We don't wait around for the sun to shine on the object. And we use short pulses of laser light to probe the atmosphere. This technique is called LIDAR. LIDAR stands for light detection and ranging. A LIDAR uses short pulses of laser light to detect aerosols in the atmosphere. NASA Langley is involved in active remote sensing from the ground and in the air. At NASA Ames in California, LIDAR is flown in the high-altitude ER-2 aircraft to record atmospheric data. And at NASA Dryden, also in California, a high-altitude solar-powered, unpiloted airplane is being developed that can stay aloft for weeks, even months, at a time to make atmospheric measurements.
So how does LIDAR work?
Well, first of all, we open this trap door and then align our LIDAR under the open sky. Then we shoot a pulsed laser beam into the atmosphere. Some of that laser beam scatters off the tiny aerosol particles and scatters light into this telescope. The light is then captured by this detector. By precisely timing the laser pulse going out into the atmosphere and the reflected light coming back to the telescope, scientists can accurately measure the location and number of aerosols. Now remember, this is active remote sensing, much like that flash on the camera.
Okay, I understand passive and active remote sensing and how LIDAR works, but how do you measure the distance from the ground to the aerosols in the atmosphere? You can't use a meter stick.
Okay, let's say you wanted to measure something far away, say like aerosols in the sky. You're right, you wouldn't use a meter stick. Scientists at NASA Langley use mathematics. A pulse of laser light is shot from point A. The beam travels from point A to the aerosols at point B. Then the light reflects off the aerosols and bounces back to point A. If you know how fast it takes for a pulse of laser light to travel, and you know a little math, then you can calculate how far away the aerosols are in the atmosphere. Check it out. It takes a pulse of light 1 nanosecond to travel 1/3 of a meter.
What is a nanosecond?
A nanosecond is 1/100000th of a second. Basically, it's a really small amount of time. Anyway, if a scientist shoots a pulse of laser light at the sky, and that beam reflects back, say in 6,000 nanoseconds, the aerosols in the sky are really 3,000 nanoseconds away. Why? Because you have to divide the total time by 2 in order to find the time one way. Got it? So, if you multiply the time one way, 3,000 nanoseconds, by the number of meters in a nanosecond, 1/3, you get 1,000 meters. If you know how to convert meters to kilometers, you can calculate that the aerosols in the sky are 1 kilometer away.